Hello, today we are going to see the motion of body in plane polar coordinate and what is velocity and its component of acceleration and some special cases like uniform circular motion, non-uniform circular motion and the plane motion in plane polar coordinate system. Let's see how. We know in plane polar coordinate system the length element will be dr r cap plus r d phi cap. And what is the metric coefficient? The metric coefficient will be 1 and r. Now what is velocity? Just differentiating with respect to time, the velocity will be dr by dt r cap plus r d phi by dt phi cap. By rewriting it, I can say r dot r cap plus r phi dot phi cap. So what is the radial component of velocity? The radial component of velocity is r dot. And what is the angular component of velocity? The angular component of velocity is r phi dot. Understand? Now what is b square? B square is the dot product of b of b. What is dot product of b of b? The dot product will give you r dot root square plus r square pi dot root square. And what is kinetic energy? Half m r dot root square plus r square pi dot root square. Here you saw the velocity component. Now acceleration component. And what is the acceleration component? By the formula I discussed before, the radial component will be 1 by m into h1. What is h1? 1. 1 by m into 1, dou by dou t by dou r dot minus dou t by dou r. Just differentiating with respect to r dot and r, I can write this will be dou by dou t r dot minus r pi dot root square, and this will be r double dot minus r pi dot root square. This is radial component of acceleration. And what is the angular component of acceleration? For angular component of acceleration is equal to 1 by m into h2. What is h2? h2 is equal to 1 by m into r, dou by dou t by dou phi dot minus dou t by dou pi. Just differentiating with respect to phi dot and pi. So what I will get? I will get 1 by r dou by dou t r square pi dot, because the kinetic energy term does not contain any pi term. So what will be it? If I extend it further, it will be 2r dot phi dot plus r square phi double dot, or I can write it r phi double dot plus 2 r dot phi dot. Just cancel the r term, and this is the phi component of acceleration. If I need to find total acceleration. What will be total acceleration? Total acceleration will be just a square plus a pi square root of. Similarly, if I need total velocity, what is the total velocity? B r square plus b pi square root over. You can calculate by just substituting a r, a pi, b r, b pi. Now see some special cases. If theta is equal to constant, if in a plane motion theta is equal to constant, then what will be? Phi is equal to constant, then phi dot is equal to 0 and phi double dot will also 0. Then what is the value of Vr? Vr is equal to r dot. Then what is the value of V pi? V pi is equal to 0. And what is the value of Ar? Ar is equal to r double dot, because the phi dot is equal to 0. And what is the value of A pi? A pi is equal to 0. So here there is no phi component, only radial component. Only radial component means it is one dimensional motion. So in plane polar coordinate, the special case of phi is equal to constant leads to rectilinear motion. Rectilinear motion. I hope you understand. Now see, what is the special case when r is equal to constant? When radius is equal to constant, I can say r dot is equal to 0 and r double dot is equal to 0. If r dot is equal to 0 and r double dot is equal to 0, then what is Vr? Vr is equal to r dot is equal to 0. Then what is V pi? V pi is equal to r phi dot, because r is constant and there is nothing about phi dot. Now what is Ar? Ar is equal to r double dot minus r pi dot square. R double dot is equal to 0. So Ar is equal to minus r pi dot square. And what is A pi? A pi is equal to r pi double dot, because r dot is equal to 0. So here we get both radial component of acceleration and angular component of acceleration. So accordingly, there is nothing condition on phi. So I can say phi can change anyway. So this is the case where r and phi both given, and this condition is known as non-uniform circular motion. Why circular motion? Because both r and phi given, but r is equal to constant and phi changes. What is phi? Phi the angle. If angle changes in a circular motion, I can say this is the case of non-uniform circular motion, because there is nothing condition on phi. and phi regularly changes. This is non-uniform case of circular motion. Now let's see when r is equal to constant and phi dot is equal to constant. When r is equal to constant, that is radius is equal to constant, and phi dot is equal to constant. If radius is equal to constant, I can get idea from the previous one, that is when radius is equal to constant, the motion must be circular. But is phi dot is equal to constant or some extra constraint? Let's see. When r is equal to constant, I can say Vr is equal to 0. And now what is V phi? V phi is equal to, we know V phi is equal to r phi dot. R phi dot. Because phi dot is equal to constant too. But what about air? Air is equal to r double dot minus r phi dot square. So r double dot is equal to 0. As r is equal to constant, r dot is equal to 0, r double dot is equal to 0, and phi dot is equal to constant. So phi double dot is equal to 0. But phi dot is equal to constant. So what is air? Air is equal to minus r a phi dot square. And what is a phi? A phi is equal to r phi double dot. What is phi double dot? Phi double dot is equal to 0. And what is r dot? And r dot is equal to 0. So a phi is equal to 0. Here only one acceleration component, that is radial acceleration component. That is the acceleration act along radius only. And no angular component, means it's through a circular motion as r is equal to constant. But in the circular motion, the angular acceleration remains constant, or the angular velocity remains constant. As a phi is equal to angular acceleration is equal to 0. Since the angular acceleration is equal to 0, I can say this is the case of uniform circular motion. So in plane polar coordinate, phi is equal to constant r, constant that the motion is rectilinear motion. When r is equal to constant, I can say it is circular motion. But as there is no constant on phi, I can say this is non-uniform motion, because in circular motion the acceleration can changes gradually as there is phi component of acceleration. But when r is equal to constant and phi dot is equal to constant, I can say this is circular motion too, as r is equal to constant. But there is no acceleration, angular acceleration component. When there is no angular acceleration component, I can say when body rotate, it does not have any acceleration. When no acceleration, so this is uniform circular motion. Okay, I hope you understand. Thank you.